Welcome to the PECO Virtual School. Our mathematics topic today is fractions. Our mode of operation, you watch the tutorials which are provided on the DVD, also available on the website and also on YouTube. However, after you've watched the tutorials, you don't end at that. Contact us to see a way of how you can get the assessments in form of questions at the end of each and every tutorial. Our numbers are provided below. Fractions in mathematics. This is Mr. Twinomugisha Lambert, who is going to facilitate this particular topic on behalf of the PECO Virtual School. So we start with the definition of fractions. A fraction is part of a whole. What does it mean? For instance, if you're in a mixed school, you can ask yourself, what fraction of boys are in S1? You can also ask, what fraction of a loaf of bread does a family consume in a day? All these give us an insight on what a fraction is. More to that, you could also ask or pose a question. What fraction of your P7 class got a first grade? What proportion of Ugandans have degrees? All these help us to understand the concept of fractions. In a fraction, the top number is called the numerator and the bottom number is called the denominator. The size of the numerator compared to the denominator will give rise to the different types of fractions. The numerator, to be brief, is the number that is always on top, and the denominator is the number that is always below. So the first type of fraction that we have are the proper fractions. Proper fractions, and in this case, the numerator is less than the denominator. The upper number is actually smaller than the lower number. For instance, when you compare or when you look at 3 out of 4, now in this case, the 3 is the numerator and 4 is the denominator. Now this is what I was referring to. 3 is the upper number and 4 is the lower number. So 3 is the numerator, whereas 4 is the denominator. So this 3 out of 4 is a proper fraction, and the reason is very simple. It is a proper fraction because the numerator is smaller than the denominator. More to that, you can also compare 7 out of 9. 7 is our numerator and 9 is our denominator. So the fact that the numerator is smaller than the denominator, 7 out of 9, is also called a proper fraction. Now another category of fractions that we have are the improper fractions. Now improper fractions are actually a reverse or an opposite of proper fractions. Why? In improper fractions, the numerator is actually greater than the denominator. It is larger than the denominator. You can give any example. The examples are so unlimited. For instance, when you take 5 out of 3, you realize that this number, the 5, which is the numerator, and the 3 is the denominator. So this 5, which is the numerator, is actually bigger than 3, which is the denominator. So meaning that 5 out of 3 is an improper fraction. Why? The numerator is bigger than the denominator. Now this is quite different from the first type of fractions we talked about, the proper fractions, where the numerator is smaller than the denominator. So with improper fractions, this upper number is always bigger than the lower number. Can also look at 8 out of 5. The 8, which is the numerator, is actually bigger than the 5, which is the denominator. So 5 out of 3, 8 out of 5 are all examples of improper fractions. You can mention as many examples as you can. Another category of fraction that we shall look at are the ones we call mixed fractions. Now a mixed fraction has a whole number, and this whole number is strictly followed by a proper fraction. For instance, 1 and 3 out of 4 is an example of a mixed fraction. Why? The whole number is this. This one is the whole number. Now this one, which is the whole number, is followed by a proper fraction. So the proper fraction here is 3 out of 4, and the whole number is 1. So this one is the whole number, and then the 3 out of 4 is the proper fraction. So a mixed fraction has a whole number and then has a proper fraction. We can mention as many mixed fractions as we can. We can also have 2 out of 5 and any other mixed fraction that you can talk about. So in the same way, a mixed fraction can be converted into an improper fraction and vice versa, meaning that an improper fraction can as well be changed into a mixed fraction. So we can change a mixed fraction into an improper fraction, and we can as well change an improper fraction into a mixed fraction, as we shall see in the subsequent examples. Now we also have another type of fractions, and those are the ones we call equivalent fractions. Now equivalent fractions actually have the same value. If, for instance, I have a half, that is 1 out of 2, and I change it to percentage, I multiply it by 100, it will give me 50%. If I have 2 out of 4 and I multiply it by 100, I also get 50%. If I have 3 out of 6 times 100, that will also give me 50%. 4 out of 8 times 100 will also give me 50%. So meaning that 1 out of 2, 2 out of 4, 3 out of 6, 4 out of 8, 5 out of 10 are all equivalent fractions. Why? Once I convert them into fraction, once I convert them into percentage, they will actually give me the same percentage, which is 50. We can check this. So once you check 5 out of 8, I can multiply the 5, which is actually the numerator, I can multiply it by 2. I also multiply the denominator, this 8 by 2, and this will take us to 10 out of 16. So what does it mean? That 5 out of 8 is actually equivalent to 10 out of 16. 5 out of 8 and 10 out of 16 are actually equivalent fractions. In the same way, 12 out of 15, I can now divide this. Instead of multiplying, I can divide it. But even if I multiply, it will have no problem. I will get an equivalent fraction. So I can reduce this. I can get 12, I divide it by 3. I get 15, I divide it by 3. So I must divide by the same value. If I divide the numerator, which is 12, by 3, I should also divide the denominator by the same value, which is 3. And this gives us 4 out of 5. Meaning that 12 out of 15 and 4 out of 5 are actually equivalent fractions. You can think of as many equivalent fractions as you can. Now we can therefore look at our first example. So example 1, convert 3 2 out of 5 into an improper fraction. So you realize that this is actually mixed fraction. Why? We have a whole number which is 3. The whole number bit here is 3, and the proper fraction is 2 out of 5. The whole number is 3, this is 3, and the proper fraction is 2 out of 5. So we have 2 out of 5, which is the proper fraction, and 3, which is the whole number. So we are now going to convert, and this is how we proceed. 3, 2 out of 5 will be equivalent to, so we shall take this whole number, which is 3. So 3 times 5, the whole number times the denominator, and then we add the numerator. So 3 times 5 plus the numerator, which is 2. Now everything out of the denominator, which is 5. I repeat that. 3 times 5 plus 2, the whole number, which is 3, times the denominator, which is 5, and then we add the numerator. So 3 times 5 plus 2, everything out of 5, and that will provide us with 17 out of 5. So the 3, 2 out of 5 is a mixed fraction. Now the 17 out of 5 is an improper fraction. So we can as well take 11 out of 5 and we write it as a mixed fraction as our second example. So this one is actually an improper fraction. Why? The numerator is bigger than the denominator. And we shall proceed and take 11 out of 5. We shall take 11 divided by 5. So when you take 11 divided by 5, we shall get two whole numbers. Remainder 1 out of 5. So 11 divided by 5 gives us two whole numbers and remainder 1 out of 5. You can check if you would convert this mixed fraction back to the improper fraction. Do we get 11 out of 5? We can check that. So we shall take 2 times 5, which is actually 10, plus 1, giving us 11 out of 5, which is the original improper fraction that we had. Example 3. Reduce or simplify 21 out of 35. We need to reduce or simplify 21 out of 35. How do we do this? So you get a number that you can easily divide, that can divide 21 at the same time divide 35. I alone said that what you divide, the value that divides the numerator should be the same value that divides the denominator. So if I divide, for instance, by 3, then I should divide by 3 throughout. If I divide the numerator by 4, then the denominator should also be divisible by 4. But when you check these numbers are not divisible by 2. 21 is not divisible by 2. 35 is not divisible by 2. 21 is divisible by 3. 35 is not divisible by 3. So I cannot divide by 3. 21 is not divisible by 4. 35 is not divisible by 4. These numbers, 21 is not divisible by 5. 35 is divisible by 5. So I need a number that can divide 21 at the same time divide 35. And realize that the number that can divide 21 and 35 is actually 7. So we are going to divide 21 out of 35. So I will take 21 divided by 7 out of 35 divided by 7. So 21 divided by 7 will give us 3. 35 divided by 7 will give us 5. So meaning that 21 out of 35 is equivalent to 3 out of 5. 21 divided by 21 out of 35 is actually equivalent to 3 out of 5. So we can now proceed to our next subtopic, and that is operations with fractions. By operations we mean addition, subtraction, multiplication and division. The first point to note, point number 1, for fractions with addition and subtraction, only we find the LCM and work out. For fractions with addition and subtraction, we simply find the LCM and work out. For fractions with plus and minus, find the LCM and work out. That is our point number 1. Now, point number 2, for fractions with combined operations. By combined operations, I mean addition, subtraction, division, multiplication of the BODMAS rule must be observed. What does BODMAS stand for? Brackets. BODMAS stands for brackets of division, multiplication, addition, and subtraction. Meaning that if you have an expression that has a bracket, then you start by computing the bracket. That's why we have brackets first. So, can we use that concept and work out this example 1? Without using a calculator, express the following as a single fraction. Express the following as a single fraction. So we have 2 out of 5 plus 3 out of 7. So what do we do in this case? So we have our 2 out of 5 plus 3 out of 7. What do we do here? We shall get the LCM of 5 and 7. And the LCM of 5 and 7 is actually 35, which is here. So the LCM of 5 and 7 is 35. LCM of 5 and 7 is actually 35. Now once you get this LCM, which is 35, we shall take 35 divided by 5, and that gives us 7. Now that 7, 35 divided by 5, we shall take the 7, gives us 7. Now 7 times 2, which is this. Now we keep this sign plus, so we keep the sign plus. Now 35 divided by 7, that gives us 5. Now the 5 times the numerator, which is 3, so 5 times 3. So once we compute this, we shall end up with 14 plus 15, everything out of 35, and that will give us 29 out of 35. So 2 out of 5 plus 3 out of 7, the LCM of 5 and 7 is actually 35. So 35 divided by 5 gives us 7 times 2, which is this. Keep the sign plus. 35 divided by 7, which is 5, times 3, which is this. Now once you get to this level, the remaining work is just addition. So 14, 7 times 2 gives us 14, 5 times 3 gives us 15, and that gives us 29 out of 35. Another example, 1, 2 out of 3 plus 2, 1 out of 4. Now you realize that these are actually mixed fractions. So to begin with, if you have mixed fractions, to begin with, the simplest way would be to convert all the mixed fractions into improper fractions, and then the procedure will remain the same. So step 1, we shall change these mixed fractions into improper fractions. So change all these mixed fractions into improper fractions, and we earlier discussed that. We talked about that, changing a mixed fraction into an improper fraction. So we shall change 1, 2 out of 3. So we shall take 1 times 3, this whole number, times the denominator. So 1 times 3 plus 2, everything out of 3, and that gives us 5 out of 3. We can also change this using the same approach. 2 whole numbers, 1 out of 4. Once we convert, we shall have 2 times 4. 2 times 4, this whole number times the 4. This whole number 2 times 4. And then you add the numerator. Everything out of the denominator, which is 4. So that gives us 9 out of 4. We have now completed the first step. We have changed all the mixed fractions into improper fractions. Now the next step, we shall go ahead and add. So 1 whole number, 2 out of 3, plus 2, 1 out of 4, will now be equivalent to, so this 1, 2 out of 3 is actually equivalent to 5 out of 3. So where I have 1, 2 out of 3, that is the same as 5 out of 3. Then we add 2 1/4, which is actually 9 out of 4 that we had got. So once we get to this level, we now follow the same procedure as in example A. LCM of 3 and 4 is actually 12. The LCM is 12 of 3 and 4. It is 12. So 12 divided by 3 gives us 4. So 4 times 5, which I write here. Then I keep the sign plus. We keep it here. So 12 divided by 4, 3 times 9. So that will give us 20 plus 27 out of 12. And we end up with 47 out of 12. You can go ahead, since this is an improper fraction, you can go ahead and express it as a mixed fraction as 3 whole numbers, 11 out of 12. Now that takes us to example 3. 5 out of 6 minus 3 out of 4. What do we do? First obtain the LCM of 6 and 4. That is step number 1. And the LCM of 6 and 4, if you calculate critically, it will be 12. Not 24, but 12. So we shall now take 5 out of 6 minus 3 out of 4 equal to LCM. Our LCM of 6 and 4 is 12 actually. So now 12 divided by 6 gives us 2. Now times 5. 2 times 5. Then 12 divided by 4, 3 times 3. Now you must keep the sign. This is a subtraction, so we must keep the sign. And that will give us 10 minus 9. That is 1 out of 12. Can you extend the same idea to this? 6 whole numbers, 3 out of 4, plus 4 whole numbers, 1 out of 3. Now these are mixed fractions. Step number 1, as we said, once you have mixed fractions, you start by changing all the mixed fractions into improper fractions. You can actually work out that. You can do some side work and work out that 6 whole numbers, 3 out of 4 as an improper fraction. Then 4, 1 out of 3 as an improper fraction. You can do that. So try to work out that and see the value that you'll get. And the value you get should now coincide with what I'm going to get here. So 6 whole numbers, 3 out of 4 will be equivalent to 6 times 4. The whole number 6 times 4. Then add 3. Everything out of 4. And that gives us 27 out of 4. Now the same approach we do for 4 whole numbers, 1 out of 3. So we shall take 4 times 3, add 1, everything divided by 3. And that will give us 13 out of 3. Now, we have successfully changed the mixed fractions into improper fractions. The remaining work is us to actually add. So we simply add, like we did in the previous questions. So we have 27 out of 4. We are adding 13 out of 3. So LCM of 4 and 3 is actually 12. So 12 divided by 4 is 3. So the 3 times the 27, which is here. Now keep the sign plus. 12 divided by 3, 4 times 13. So we shall compute that. We end up with 133 out of 12. This is an improper fraction which you can go ahead, as per the procedure we talked about, to have 11 whole numbers and 1 out of 12. That now takes us to example E. So we have a half minus 3 out of 4 plus 5 out of 8 minus 7 out of 16 plus 19 out of 32. How do we do this? First, observe the question critically. Which operation signs do we have? We simply have addition and subtraction. So in this case, we said that once you have addition and subtraction, simply get the LCM and work out. There is no trick in this. Just get the LCM and proceed to work out normally. So in this case, the denominators we have are 2, 4, 8, 16 and 32. So we are going to get the LCM of these. So can you do some side work and get the LCM of 2, 4, 8, 16 and 32? So let's do side work and obtain the LCM of 2, 4, 8, 16 and 32. So the LCM is actually 32, and then we shall proceed and work out normally. A half minus 3 out of 4 plus 5 out of 8 minus 7 out of 16 plus 19 out of 32 equals, our LCM is actually 32. So our LCM is 32. So I will now get 32 divided by 2. 32 divided by 2, which is 16 times 1. So I write it here. Keep the sign minus 32 divided by 4, 8 times 3, which is actually here. Keep the sign plus 32 divided by 8, which is 4 times 5. 4 times 5, which is reflected here. Keep the sign minus. We keep the sign minus. So 32 divided by 16 is 2 times 7, which is actually here. Add, because this is an addition, plus, which is the same here. So 32 divided by 32, 1 times 19. So these values are actually coming from this. 32, let me repeat the steps. The LCM is 32. So 32 divided by 2, 16 times 1. You write it here. Keep the sign minus 32 divided by 4, 8. 32 divided by 4, that gives us 8 times 3, which is here, but with this sign kept, plus, now 32 divided by 8, 4 times 5, which is actually here. 32 divided by 16, 2 times 7, but we keep the sign, plus 32 divided by 32, 1 times 19, which is actually here. So we compute that and simplify to have 17 out of 32 as a final answer. You can always verify these answers with your calculator. You just put the values in your calculator, take your 16, you subtract 24, add 20, subtract 14, and then add 19. That will give you 17 out of 32. So can we now look at another concept in example 6? 2 out of 3 of 4 out of 5 of. What does of in mathematics imply? It implies multiplication. So meaning that we shall have 2 out of 3 times, where there is of you simply put times. So 2 out of 3, instead of writing of, you can as well put times. So we shall have 2 out of 3 instead of times 4 out of 5 equal to, with multiplication I multiply the upper numbers together and the lower numbers together, numerators together and then denominators together, and that will give us 2 times 4 out of 3 times 5. That gives us 8 out of 15, as simple as that. So once you find an of in mathematics, simply know that that is a multiplication. Question 7, rotating on that, 3 out of 8 times 4 out of 9. What do? multiply the upper numbers together. 3 out of 8 times 4 out of 9. So I can multiply 3 times 4 out of 8 times 9. So that gives us 12 out of 72. And once you reduce that, you end up with 1 out of 6. Another student, since it is multiplication, would have reduced this by 3 once, by 3, 3, by 4 once, by 4, 2. So 1 times 1 gives us 1. 2 times 3 gives us 6, which still takes us to exactly the same answer. Can we extend the same concept to example 7? 3 out of 8 divided by 2 whole numbers, 1 out of 4. This is an example that has division. So step number 1, before we divide, you realize that we have some mixed fractions. So step number 1, can we change the mixed fraction into an improper fraction? That should always be the case. In case you find that you have a mixed fraction, the easiest way, change that mixed fraction into an improper fraction. So we shall have 3 out of 8 divided by 2 whole numbers, 1 out of 4. So our task is now to first change this. This is a mixed fraction. First change it into an improper fraction. So we shall have 3 out of 8 divided by, now change this, we already did that. So this is 2 times 4, which is 8 plus 1. That is 9 out of 4. How is the 9 coming in? 2 times 4 is 8. Add 1. 9 out of 4. 2 times 4 is 8. Add 1. 9 out of 4. So we now proceed. This will be 3 out of 8. Now we shall change this division into a multiplication. So times the reciprocal of this. So the reciprocal of 9 out of 4 is actually 4 out of 9. With the reciprocal, we simply take the numerator to be the denominator and the denominator to be the numerator. So the reciprocal of 9 out of 4 is actually 4 out of 9. And then ordinary multiplication will apply, and of which you can actually even cancel here. By 3 once, by 3, 3, by 4 once, by 4, 2. If you don't want to do that, you simply multiply. 3 times 4, 12. 8 times 9, 72, which you can now reduce to 1 out of 6. Simple as that. So with the division and multiplication go hand in hand. If you're dividing, you simply change the division into multiplication and then take the reciprocal of the next number. So can we now look at questions that are going to involve the board mass as our second example? So without using a calculator, simplify the following fractions. So we have our fraction there. So study that critically. We are going to make use of board mass. Why? Why are we making use of board mass? We have brackets, we have subtraction, we have division. In this case, there is no way we can compute this minus making use of the board mass. So with board mass, I earlier said that B stands for the brackets. So what are you going to do? We first compute what is in the brackets. So before we compute what is in the brackets, let us first change all these. You realize that we have mixed fractions. Let us change all these mixed fractions into improper fractions. Can you do that? I'm going to provide only 2 minutes for you guys to convert these mixed fractions into improper fractions. So 2 minutes, and then you check if your answers will be in line with the answers that I've actually got. So the first fraction, which is 2.5, should give us 5 out of 2. Then we have 4 out of 3, and then 14 out of 9. So after you've done this, we now look at the bracket. Let us first handle the brackets first. So 5 out of 2 minus 4 out of 3. What is our LCM? Our LCM of 2 and 3 is actually 6, which is here. 2 and 3, the LCM is 6. So 6 divided by 2, 3 times 5, which is here. Keep the sign minus. Now 6 divided by 3, 2 times 4. So now this division we shall say times the reciprocal, which is 9 out of 14. So we get this value in the brackets. So this is 15 minus 8. Everything out of what? Out of 6 in our brackets. Then times 9 out of 14. So this one, the bracket here, will take us to 7 out of 6. How is the 7 coming in? 15 minus 8 actually gives us 7. Now times 9 out of 14. Now you can decide to reduce at this level. Feel free. I can decide to reduce because 7 and 14 have a relationship here. So you can decide to reduce. Or if you don't want, you can multiply and simplify further. So whichever way, we should be coming up with the final answer for that particular expression. So we also have another question here that has board mass. We can study it. So which operation signs do we have? We have of, we have brackets, we have addition and subtraction. As per the board mass, we shall start by computing the brackets of. So we are going to compute these brackets here. First, compute what is in the brackets. And what is in the brackets? 2 out of 3 minus 1 out of 4. So we shall take 2 out of 5 of means multiplication. Now we work out the brackets first. The LCM of 3 and 4 is actually 12. So 12 divided by 3 is 4 times that. So 4 times 2. Keep the sign minus 12 divided by 4, 3 times 1. That is what we get from the brackets. And then the other things remain the same. So we shall have 2 out of 5 times. Now this is 8 minus 3, which is actually 5 out of 12 plus 1 out of 2. Now we have got rid of the brackets. Which operation signs are we remaining with? We have multiplication, we have addition. Now as per the board mass, multiplication and addition, which one comes earlier? Realize that brackets of division, multiplication, addition, and then subtraction. So multiplication is done before addition. So we are going to work out the multiplication here. So we shall take 2 times 5 out of 5 times 12, and then we add 1 out of 2. So that gives us, because you realize that this 5 and this 5 can cancel, and then 2, 1, 2, 6, that gives us 1 out of 6. So this one actually here, this part here, the multiplication, which is 2 times 5 over 5 times 12, gives us 1 out of 6. So do not get confused. Where is the 1 out of 6 coming from? It comes as a result of simplifying this. Once you simplify this, 5 and 5 will cancel by 2 once, by 2, 6. So we shall have 1 out of 6 plus 1 out of 2. So LCM of 6 and 2 is actually 6. So 6 divided by 6, 1 times 1, which is here, 1. 6 divided by 2, 3 times 1, 3. That gives us 4 out of 6, which we can simplify to give us 2 out of 3. So realize that once you have more than one operation, then the board mass must apply. If I have only addition and subtraction, I simply get the LCM and multiply and compute. If I have of, I have addition I have division, I have multiplication, I have subtraction, then I'll make use of the board mass.